AS Applied Maths Statistics, we're looking at chapter 5.3, mutually exclusive events. So mutually exclusive means two events that cannot occur at the same time. They are said to be mutually exclusive. So here we are looking at the mutually exclusive events. We've got a Venn diagram drawn, which is what we've just been using and shading in, and because our events can't occur at the same time, we don't have an intersection. So when we're looking at the Venn diagram, these two don't overlap, and that's really important to recognize because it does make the question a lot easier. And so we end up with the result that if we have mutually exclusive events, the probability of A and the probability of B is equal to 0 because they cannot happen at the same time. We also can write it in notation like we have done here. Remember, that was the empty set, and we talked about that in example 5.1.5. So looking at these two events, if I've got a random experiment, so any random experiment, if I've got A and A dashed, are they mutually exclusive? Just go through this table, have a think about yes, no, and then your reason why. So looking at this, remember A dash means A not, so it doesn't happen. So A and not A, are they mutually exclusive? Yes, because it is impossible for something to happen and not happen at the same time. The next random experiment would be two fair dice that are being mulled, and our events that we are considering, the sum of the score is 4 and both dice land on the same number. So what you are asking is, can that happen at the same time? You could always refer back to your sample space that we did right in the first section where we looked at the scores of two dice if you wanted to check, and it might be with a question like this, if you asked to prove it, you might draw part of that sample space out to kind of show what was happening. So the answer is no. If you got a 2 on both dice, you would result in getting a sum of 4. And the final one, tossing a coin twice, and my events are getting 2 heads and getting a tail in the first toss. Well, obviously that can't happen at the same time, so they are mutually exclusive, because if I get 2 heads, then the first toss was a head and it's not a tail. So looking at example 5.3.2, and I'm going to do these examples with the use of a Venn diagram. So I am told in the question that A and B are mutually exclusive. So as soon as I see that, I know that I've got a Venn diagram that looks like that, and I would consider drawing that down. Before I start the question, I'm going to fill the Venn diagram in. I would start at the middle, but that is 0. Probability of A equals 0.2, so that's that section there. Probability of B equals 0.4, and the whole thing has to add up to 1, so this must be 0.4 on the outside, and now it should be quite straightforward to write these down. So the probability of A or B is equal to, well, A or B, A would be that section, B is that section, or is everything that I've highlighted, so it's 0.2 add 0.4, which is equal to 0.6. Probability of A and not B. So if I was looking at this question, we would be doing probability of A is that bit, probability of not B is that section, and I am looking for and, so I am looking for the overlap, so the answer to that one is 0.2. And finally, part C. Probability of not A and not B. Well, we've already highlighted not B in green, so if we look at not A, that would be that red section, and my overlap between the green and the red, so not A is in red and not B is in green, the overlap between those two is on the outside, so the answer is 0.4. So the Venn diagram has made that a lot easier. Looking at example 5.3.3, we've got two events. We are not told in the question that they are mutually exclusive, but what we are told is that we've got this probability of A intersection B, and remember that means and a lot of the practice questions that you come across will use the notation even though we don't need it until next year for any exam questions that we do, but we might as well get used to it. So probability of A and B, so we know they are not mutually exclusive. So this is an example where the events are not mutually exclusive. So when I am drawing my Venn diagram, I need the overlap, and we are going to do this with Venn diagram. Just there is a printing error, so or a typing error. If you just add the probabilities in, so P, there should be a P there, and we should have a P there, and we should have a P there, just to correct the question. So the first thing I'm going to do is look at the Venn diagram, and because the events are not mutually exclusive, I'm going to draw it with an overlap. I know probability of A intersection B is 0.2. So that's going to go in the middle. Remember, we start in the centre. Probability of A is 0.6. That is that whole circle there. So if the centre is 0.2, then this bit here has to be 0.4 because 0.4 add to 0.2 equals 0.6. And similarly for B, we have 0.1 because I need that circle to add up to 0.3. So then I've got 0.4, 0.6, 0.1, so I know that on the outside I have 0.3, so that the whole thing adds up to 1 in total. So then we can come on to the questions. So probability of not A. So the probability of not A, dash gone into the bracket, probability of not A is anything outside of that circle, so it's the 0.1 and the 0.3. So we've got 0.1 at 0.3, which is 0.4. A union B, that is OR. So A or B. So when we do this one, it's easier to just highlight it. So probability of A, if we put that in, is that bit. Probability of B, if I was to put that in, is that bit, and I am looking for OR, so I am looking for the combination of all of those crosses, which is 0.4, add 0.2, add 0.1. Note I'm not adding the 0.2 in twice just because it's got two crosses. I'm only using it once. That's what the Venn diagram does. It sorts out the probabilities so that we don't include things more than once. And we've got 0.7. We could have done that, especially with having the 0.3 there, by just thinking, well, it's everything apart from the 0.3. So I could have looked at that by doing that calculation as well. Part C, probability of A intersection not B. So we've already got probability of A written down. We know it's the crosses. If I'm doing not B, so let's have a look at that in a different colour. So not B is anything on the outside of the B circle. Intersection means and, so I am looking for where I have an overlap. So the intersection is the overlap. Remember, I'm doing red and blue, therefore the answer is 0.4, and because of the Venn diagram it is easy to just read off. So D, the probability that we have only one of A or B, so only one of them can occur, so only one of them. So if I'm looking at that, it's either A or it's B. So if it was A, it would just be in this section here, not including the intersection, because then obviously B is occurring at the same time. And if it was just B, it is that section there. So this bit here, it's where the 0.1 is just referring to just B on its own. So we get 0.4 add 0.1, which is 0.5.